Introduction to Computer Vision and OpenCV. Computer Vision. Computer vision is a field of study that involves teaching computers to interpret and understand images and videos. It is an interdisciplinary field that combines knowledge from computer science, mathematics, physics, and engineering to create intelligent systems that can perceive, analyze, and interpret visual data. Computer vision can be defined as discipline that explains how to reconstruct, interrupt, and understand a 3D scene from its 2D images, in terms of the properties of the structure present in the scene. It deals with modeling and replicating human vision using computer software and hardware. It is the construction of meaningful descriptions of physical objects from their image. The output of computer visions is description or an interpretation of structures in 3D scene. Applications of computer vision. Robotic applications. Location identification of the robot. Navigation. Obstacles avoidance. Assembly, e.g., welding, painting, etc. Human-robot interaction theory. Medicine applications. Classification and detection, e.g., lesion or cells classification and tumor detection. 2D/3D segmentation. 3D human organ reconstruction, MRI or ultrasound. Vision-guided robotic surgery. Industrial automation applications. Industrial inspection, defect detection. Assembly, barcode and package label reading. Object sorting, document understanding, e.g., OCR. Security applications. Biometrics, iris, fingerprint, face recognition. Surveillance minus detecting certain suspicious activities or behaviors. Transportation applications. Autonomous vehicle. Safety, e.g., driver vigilance monitoring. Image processing and computer vision are two closely related fields, but they are not the same. Image processing involves manipulating and enhancing images using mathematical operations and algorithms, whereas computer vision involves extracting meaningful information from images and videos. In other words, image processing is a subset of computer vision. Computer vision has several challenging problems that researchers are still working to solve. Some of these problems include object recognition, image segmentation, tracking, and 3D reconstruction. These problems are challenging because images and videos can vary greatly in terms of lighting, scale, and viewpoint. OpenCV. OpenCV is a cross-platform library using which we can develop real-time computer vision applications. It mainly focuses image processing, video capture, and analysis, including features like face detection and object detection. OpenCV was originally developed in C++. In addition to it, Python and Java bindings were provided. OpenCV runs on various operating systems such as Windows, Linux, OS X, FreeBSD, NetBSD, OpenBSD, etc. Using OpenCV library, you can read and write images, capture and save videos, process images, filter, transform, perform feature detection, detect specific objects such as faces, eyes, cars in the videos or images, analyze the video, i.e., estimate the motion in it, subtract the background, and track objects in it. Installing OpenCV from source takes up a lot of time, depending on your hardware and the installation configuration. Installation instruction for OpenCV. Go to anaconda.com. Download and open Anaconda distribution installer. Select checkbox to add Anaconda to path environment variable during installation. Open command prompt. Create virtual environment. Press 1. Activate virtual environment. Install OpenCV. Press 1. Check OpenCV installation. Installing OpenCV for Python. Step 1. Install Anaconda for Python 3. Download and install Anaconda Python 3 version from Anaconda's download page. Step 2. Create a virtual environment. We will use virtual environment to install Python libraries. It is generally a good practice in order to separate your project environment and global environment. Open the command prompt or PowerShell and execute the following command. Conda create, name virtual in Python equals 3.8. Step 3. Install OpenCV on Windows. Activate the environment we created just now, virtualenv. and install all the required libraries using the commands below. Conda activate virtualenv. Pip install OpenCV contribution Python. Install OpenCV on Windows for C++. Step 1. Prerequisites. You need Visual Studio pre-installed on your system. You can download the latest version of Visual Studio for that. Step 2. Download the installer. Once you have set up Visual Studio on your system, download the OpenCV installer according to the Visual Studio version you have installed. Step 3. Install OpenCV on Windows. Once you download the installer, double-click it to run the installer. Once software installed, run the sample code. OpenCV library modules for Python. Core functionality. This includes the basic data structures and functions used in OpenCV applications. Data structures include scalar, point, range, etc. Image storage. The primary data structure for images is the multidimensional array MAT, which stores image data. Image processing covers fundamental image processing operations. Filters. Image filtering techniques like Gaussian blur. Geometric transformations. Resizing, rotation, etc. Color conversions. Transformations between color spaces, such as RGB to grayscale. Histograms. Calculating and analyzing image histograms. Python equivalent. Available via the CV2 module, e.g., cv2.cvtcolor, cv2.gaussianblur. Video analysis. Includes modules for motion estimation, background subtraction, object tracking, Python equivalent. These features can be accessed via CV2. Video I/O. Used for capturing video streams from cameras, reading/writing video files with codecs. Python equivalent. Functions like cv2.videoCapture and cv2.videowriter. Calib 3D. Focuses on multiple view geometry, camera calibration, single and stereo camera calibration, 3D reconstruction, stereo correspondence, and depth estimation. Python equivalent. Functions such as cv2.calibrate camera and cv2.stereorectify. Features 2D. Handles. Feature detection. Algorithms like SIFT, SURF, ORB, etc. Description and matching. Python equivalent. Use cv2.sif_create, cv2.orb_create, and related methods. Object detection. OBJDetect. Covers detection of predefined objects like faces, eyes, cars, etc. Includes pre-trained classifiers for objects. Python equivalent. Use cv2.cascade classifier for object detection. HiGA provides simple UI capabilities for displaying images and videos. Image/video codecs, handling input, output. Python equivalent. cv2.imshow for displaying images. cv2.imwrite and cv2.videoCapture for saving/reading.